Today in the workshop, we'll take a look at prototyping your projects. After discussing the design process, I'll show you the items that I use to prototype my electronic, Arduino, and Raspberry Pi designs. We've got it all planned out today, so welcome to the workshop. Hello and welcome to the workshop. Today we're going to be doing something slightly different. We're not going to be looking at a specific component. What we're going to be looking at is the design and prototyping process, the process that you need to go through when you're taking a circuit and building it, whether you're doing it just as an experiment or whether you're actually wanting to build something permanent out of it, either one device or dozens and dozens of devices. And so what we're going to be looking at are things like the solderless breadboards that we use, some of the test equipment and the little jigs and that we can use with Arduinos and Raspberry Pis to make life a lot easier, some of the little things we can use for testing and troubleshooting when things don't exactly go correct, and also some of the construction materials we would use for building one-off prototypes. Now, I know this doesn't seem as exciting perhaps as building a new circuit or having some new code for the Arduino, but this is an essential skill that you need to have. If you want to start working in the workshop, you're going to need to know how to prototype. Now, there are a few tools and devices that'll make your life a lot easier. I'll be showing you that, but basically not any of this is really very expensive, and so it's an essential thing for anybody's workbench. So what we're going to do is start off by talking about the design process, what we do to take a circuit from the point where we're first imagining it or seeing something on the internet that intrigues us into bringing it to becoming a final product. So let's go through and take a look at that right now. Now, there are several ways of breaking down the design process. I'm going to break it down into 4 different steps today. The first step is the circuit design, which may also include some code design if this is a microcontroller or microcomputer based project. The next step is breadboarding. The third step would be testing and troubleshooting. And the fourth step would be actually prototyping or building the final project. You can get your circuit and code designs from several sources. Tech websites are an excellent place to look for designs. Manufacturers' data sheets often have complete circuits in them as well as code samples. GitHub is of course an excellent place to get all sorts of code design. And there are also the traditional books as well as other sources. Breadboarding is the process of hooking up the components for testing your design. The most common method of doing this is with a solderless breadboard. You can also use components mounted on breakout boards that make it a lot easier to connect them up. You'll be needing jumper cables or wires to make the connections. You'll also need a suitable source of power for your project. Once your project has been built and coded, it's time to test it for its desired operation. You can use breakpoints and monitors to look at the code results. You can use test equipment to test voltage and current levels at key points in your project. This is the stage at which you'll have to troubleshoot any non-functional areas. You can continually repair and improve your project until it's perfect at this stage. Now at last it's time to prototype or build the project. You may wish to make a prototype project for something that you're planning on manufacturing at a later date. If you're only building one project, this is the time to build the final product. You can wire it up with Perfboard, or you can even design a printed circuit board for your project, although it's advisable to use Perfboard first if you're going to do that. So now let's get to work. So now we've seen the design process, it's time to start looking at the tools we use to go through that process. And the most commonly used piece of equipment is, of course, the solderless breadboard. Now there are several different styles of solderless breadboard, and I'll show you a few different styles, but I'll also show you a few different accessories for solderless breadboards that you can use to make some of your breadboarding easier. So let's take a look at solderless breadboards right now. Now here are a number of different solderless breadboards, a few different styles and sizes of breadboards for you to look at. The basic concept of any of these breadboards is the same. They have holes that are 0.1 of an inch apart in both directions. Now 0.1 of an inch is the standard spacing for pins on an integrated circuit like this one. And you can plug the circuit directly in to the breadboard. Now the pins on the breadboard going in this direction are all connected together. So if I needed to connect a wire to this pin on the integrated circuit, I could just take a wire, and this is just a piece of 22 gauge solid wire, and I could insert it in the breadboard, and now this wire is connected to this pin on the IC, and it can be wired off to anywhere. Now the 5 pins going this way are connected. The 5 pins going this way are connected. They're broken in the middle so that you can place ICs inside here. You can also place other standard components into the breadboard as well. Like, for example, a resistor can be easily placed inside your breadboard, as can a tiny capacitor. I'm not wiring any specific circuit here right now. And then, of course, you can connect wires to those components as well, or you can use the component leads themselves to run, whatever is easier. Now, on the breadboard, you'll also notice some rails on the side. Now these ones are connected down in this direction over here. They're separated, and there's a blue and a red one, and this is for positive and negative, and they happen on both sides of this style of breadboard. And this is for your power supply voltages, so you could place your 5 volts here. You could even have 2 different supply voltages, so like 3.3 volts on this one and 5 volts over here. And then you can make all your connections to ground and your VCC. Now these breadboards are available in a number of different sizes. Here's a larger one. This is a very, very common type of breadboard, and a very popular breadboard. Now one thing to note about these longer breadboards over here, this isn't necessarily true for all of the different models, but if you look down over here at the power rails over here, a lot of the times those power rails only go halfway, and they're broken over here in the middle, and so you'd have to place a jumper going this way if you want to continue the power rail. That again is made so that you can use multiple power supplies, but it throws some people for a loop if they're not aware of that. That's not true of all models, but it is of several of them. Now breadboards themselves can be snapped together. They have little tabs on the side, so I can take 2 solderless breadboards and make a bigger solderless breadboard, and that's true of all the different sizes. Now you need to use the same manufacturer breadboards so that they can snap with each other, so these half-size ones here will not fit this one just because they happen to be from a different manufacturer. On these breadboards you can also pull off the power supply rails as well too, and you can even lock them together if you wish to make you know, your own power supply breadboard or a power supply for another project. Now this is the most common style of breadboard over here, but there are other ones. There are these little mini breadboards, and these are only connected across this way. They're not connected in here, so again you can place an IC across them. And they don't have any power supply railings, but these are very good just when you need to connect a few wires together. You don't have that much to do. You can use these tiny breadboards. They're great for prototyping where you just need 1 or 2 parts. Now I've got over here a different style of solderless breadboard. You may run into these as well. This was actually sold as a piece with these breadboards mounted on here with power supply rail going across over here, and with these connectors on it. I added these binding posts and this connector and just wired them at the back over here, and then added some legs to lift the whole assembly up. This is an older style solderless breadboard. You don't see them as often now, but I remember these going back to the 1970s. Again, it's the same concept. You've got the pins going across this way, and you can plug your components into it. Again, these power supply rails are actually split in the middle here, so they don't go through. You'll notice this style only has one rail on each side, and unlike this style of breadboard, you can't separate it off. You can't pull it off of the breadboard. It is attached to the board. But otherwise, these are still quite usable breadboards. As I said, I remember these ones from back in the 1970s, so they've certainly been around for a while. Now, when you're using your breadboards, you're going to want to use some wires, and as you saw, I could just use a piece of 22 gauge solid wire, and you can use different colors of wires, which is helpful because when you're wiring stuff up, it's helpful to be able to keep track of the connections, and you can set standards like using red for your positive power supply and black for your ground, etc. But another thing you can do is you can buy these pre-made breadboard wires, and I've got a whole selection of them over here. They come in a variety of different sizes, and I have my different sizes separated out into different compartments over here. I've also taken some of these cables. I've got a series of these kind of cables which are very handy for breadboarding, and you can get them. This is female to female over here. This is male to what is this? This is male to male. I've got male to female over here, and these wires will pull off as well, and I've actually pulled a few of them off and used them over here to make male to female connectors, which can come in very handy when you're connecting to an external device such as a Raspberry Pi or an external sensor and want to just bring the connection onto your breadboard. Now, the nice thing about all these pre-made connections, of course, is that you don't have to go stripping a bunch of wires. They are available in a number of different sizes. You have to watch them, though, because sometimes these little connectors come off. Actually, they use, most of them, stranded wire, and the crimp them on the pins here, so the wire is a bit more flexible, which sometimes is an advantage. But at any rate, there you go, the essential prototyping tool, the solderless breadboard. So here's a solderless breadboard with a number of components mounted on it and a number of connections made to an Arduino, along with some external devices like a LCD display, and even back over here a few servo motors that are mounted on a little holder over here. And what I wanted to illustrate with this is not only how you wire stuff up on a breadboard, but also breadboard friendly components. Now, this breadboard, as you can see, has been mounted on a steel plate and with a couple of binding posts. It came that way. I mounted it to this board with a mouse pad because I find the mouse pad is a very nice thing to hold Arduinos and other external components. It kind of grips them a bit and it holds them down, so there's a trick for you. One thing about this breadboard I wanted to illustrate is that it is using some breadboard friendly components. For example, you can see these pots over here. I can pull these out, and these are made to go specifically into breadboards. Now, standard electronic components usually are on a 0.1 of an inch grid, so they'll fit into breadboards, but that's not necessarily true of pots. So these ones, which came from Adafruit, are really nice for using in breadboards. Another thing is this servo motor driver. It's breadboard friendly because it has a right angled DuPont connector at the bottom, which plugs into the breadboard. Now, one thing about things like this pot and these connections is they are breadboard friendly. However, if you continually use these in a breadboard, you will start to expand the connectors. So you have to expect that your breadboard may not have a huge lifespan, a few years or so, and then after that, if you've used it a lot, you may need to replace it. You may find the connector is getting intermittent. There's a couple of other components I can show you over here. Let me just move our breadboard out of the way. Now, this is a breadboard friendly component that I made myself. This is just simply a potentiometer with a couple of solid wire leads soldered to it. So you can do that with a number of your components as well and make it very easy to prototype with them. Another breadboard friendly item, I've got a solderless breadboard over here, is this power supply. Now, this is a really nice little unit. These are very commonly available on eBay and Amazon, and this is really a great unit in that you can put a USB cable or a 9 volt or 12 volt adapter in here. There's a power switch on it, and it supplies both 3.3 and 5 volts using a couple of linear regulators, and you can strap over here what voltages you want. The great thing about these is that they are breadboard friendly. They plug right into the rails on a breadboard like that, and then they will actually power the two rails on this style of breadboard. So if you can see that, that is really a handy thing to have. It also takes care of the bench power supply considerations some of you may not have. Other breadboard friendly components include things like this simple little push button switch. This is a push button switch that will mount right across the middle over here on the breadboard, and is really very handy because you often do need a push button in your project, and you can get these in both black and red, maybe even a few other colors. And so there you have it, a few components that will make your breadboarding life a little bit easier. So with one or two solderless breadboards, some jumper wires, and perhaps a breadboard power supply, you're pretty well equipped to do any electronic experiment, especially those working with Arduinos. However, when you're working with Arduinos, there are some additional accessories that can make your life a lot easier. So what we're going to do right now is take a look at some of those accessories, those prototyping tools that are specifically made for working with Arduinos. I'll also show you a couple of jigs that I've created myself, some homemade ones that you might want to duplicate for your own Arduino work. Now here are a selection of items I have that make prototyping with the Arduino a lot easier, and a lot of these work with different models of Arduinos as well. So here I've got an Arduino Uno, and for the Uno, the first thing we have is this prototyping shield. Now this is a shield that will fit on top of the Uno like this, and it brings out a couple of things like the reset button, which you wouldn't be able to reach otherwise with a shield on top of it. There's also in this particular one a test button, which is just wired up that you can wire yourself. This shield has a place for a number of different components that you can put on. It brings out things like the SPI bus, and it also brings out all the connectors on the top over here. Now here's another version of the same type of a shield, and this one has a small solderless breadboard on it, so this is very convenient. You can place this on the Arduino and have a solderless breadboard, and it might be all that you need. You might not need an external solderless breadboard. Another thing for the Arduino Uno is this sensor shield over here. Now this makes prototyping a bit easier because a lot of times what we're doing is we're hooking up sensors, and our sensors have pretty well the same pattern. They have a pin that goes to a digital pin, they've got a ground and a VCC. So they've wired all of these over here to make it a lot easier for you to work with sensors. They've also allowed you to provide an external power supply for these, because in addition to sensors, you could be powering things like servo motors over here, so you'll want to add an extra supply, so you can supply the VCC externally. It also brings out the analog connections as well, so you can add potentiometers, etc. And things like the I2C connection, etc. are brought out to 4 pins over here, as well as connections for liquid crystal displays and Nokia displays and other sorts of common items that you would be connecting to an Arduino. So again, a very handy little prototyping shield. Now these ones over here, and these are all basically the same kind of things, these are screw shields, and I really like these because what you can do with a screw shield like this is you can place the shield onto your Arduino like that, and then you can place another shield. Let's just say this was another shield I had to place on. Will go on the top over here. And that way, if you've got shields like displays and things like that, you can place them on the top and still get access to all of the pins on your Arduino with a number of screw connectors over here. So I think that's really great. I've got a few different styles of these screw shields over here. This one over here. This is another one I just picked up. I really like this one actually. This is a screw shield that's got a few extra components on it as well too. Also, this particular shield also brings up the in-circuit serial programmer connections on the Arduino, whereas that one doesn't. So if your top board needs it, you'll need that. But in addition to having the reset button with this shield also had. It's also got a couple of extra pins over here connected that you can use for basically your own purposes, and they're wired down over here onto the board, so you could in addition create your own circuit and be able to get at it even if you've got a shield on top. So that's a really nice one. On the other end of the spectrum, I just got these as well too. They're rather amusing. These are also screw shields, but they come as two independent screw shields like this, and essentially you use one on each side. Like I'll put one onto here, and that gives me this side over here, and the other one goes on the other side, and then once again you can snap another component like another shield on top of this over here. This one of course is a lot lower quality in a sense. The other ones, it's just one single breadboard, but it's still a very useful item, not to belittle it in any way. Now for an Arduino Mega, I've also got an equivalent type of a shield. Again, I can place this shield onto the Mega, and this has the pins going straight through, so I can plug another shield if I wanted to onto the top as well and get access. And I can also prototype things. I like these for when I'm building projects. For example, my robot, I'm going to be using one of these where I just solder a number of connectors over here, and then it makes it a lot easier and more secure to connect to the Arduino itself. They bring again all the pins out so that you can solder to them, so that's a handy thing for the Arduino Mega. Now, not to be left out, this one is made for the Arduino Nano, and again it's a screw shield that lets you plug in your Nano into the socket over here, and after plugging in the Nano you will be able to get at all of the pins, which are nicely labeled for you, and again use screw terminals, and you can feed wires, including jumper wires for breadboards, into those terminals, and that's handy. Now, I couldn't find a commercial one that worked with the Arduino Pro Mini, so I just made my own. I just soldered a couple of these female headers and then some male headers, and literally just soldered them together over here on a piece of Perfboard, and that way I can plug my Arduino Pro Mini in and be able to get at all the pins for breadboarding purposes, etc. I did the same thing over here. You can do it for custom modules. This is for an ATtiny module that plugs in, and I did basically the same thing for that over there. So these are a couple of the things that you can use to help prototype with the Arduino Uno. They'll make your life a lot easier when working with the Arduino, not just the Uno, but other Arduinos as well. So now that we've seen some of the prototyping accessories that we can use with the Arduino, let's focus our attention on the Raspberry Pi. Now, the Raspberry Pi has a 40-pin GPIO connector on it, and you can use that to connect devices up to a solderless breadboard. And you could use male to female wires if you wished, and just connect the wires directly to the GPIO pin, and that'll work fine. But there are also accessories that snap onto that GPIO. Now, keep in mind that the Raspberry Pi GPIO has been adapted by many microcomputer board manufacturers, so you can use this with boards other than the Raspberry Pi as well. So once again, let me show you some Raspberry Pi specific breadboarding tools, as well as a couple of things that I've created myself in order to make working with the Pi a bit easier. Now, here are some items that are designed to make your life easier when working with a Raspberry Pi or any microcontroller board that uses the same 40-pin GPIO connector. Now, of course, there are several models of Raspberry Pi. I've got a Raspberry Pi 3 over here and a Raspberry Pi 0 over here. They both use the same 40-pin connector, the 40-pin GPIO, although the Pi 0 does not come with the connector unless you order the Pi 0 WH, which means with header. However, not having a connector can actually be a handy thing. If you only want to use a couple of pins on the GPIO, you could solder wires directly to them, or solder small connectors just to those pins instead of using the full 40-pin connector. Now, when working with the Pi 0, there's a couple of other accessories unique to the Pi 0 that you might want to have. One of them is this. This is just a micro USB to full-size USB connector, because the I/O port on the Pi 0 is a micro USB, as is the power connector. And the other thing you might want is to take the mini HDMI connector that they have over here and convert it to a full-size connector with this, so you can plug your video monitor in a bit easier. But otherwise, everything here will work with any model of Raspberry Pi or equivalent. Now, the most common troubleshooting tool, the most common prototyping tool, I should say, for use with the Pi is something called a T-cobbler. And this one I've got is I actually keep it permanently on these breadboards here so I can experiment with the Pi. But this T-cobbler brings all the connections on the GPIO out to 2 rows that can be plugged into a solderless breadboard. And it connects to the Pi using this 40-pin ribbon cable. Now you can connect it directly to the Pi, or you can make a little adapter like I did over here. And I don't know if you can see that, but I've got an adapter with a right angle connector on it that has a connector that also allows me to attach an additional hat on here. And I'm using this right now to test out the Google AIY voice kit, but you could use it with any hat and a Pi. So this lets you get all the GPIO pins even though I have a hat plugged in. Now the way that I made this was I used one of these little connectors, which I find really handy for the Raspberry Pi. I used one of these connectors with the extra long pins in it and soldered it right through like that. And then I took a right-angled header connector and put it on the other side like that. So I ended up with a mechanism looking a bit like this. It took a little soldering, but what I have over there is a way that I can attach my T-cobbler and at the same time keep a hat on the Raspberry Pi. So that can be very handy. And finally, another thing I find very useful and always keep around are these small proto boards. Again, they have the 40-pin connectors brought out, but they also have just an area here that you can do some prototyping on. And so if you're making a small project, or indeed a small hat, or what they call a P hat, because this has the same form factor as the Raspberry Pi Zero, you can use one of these little boards to wire it up if you don't have too many components. So that's very handy for prototyping as well. So now you've got your solderless breadboard plus a number of specialized jigs for the Raspberry Pi and the Arduino, and you're all set to do your prototyping. However, there is another aspect to development that should be considered as well, and that is testing and occasionally troubleshooting your design. Now, in order to do that, you're going to need some test equipment. Now, of course, you can spend thousands of dollars on test equipment on things like oscilloscopes and signal generators and frequency counters, but you don't need to do that when you're starting off. However, there are a couple of essential pieces of equipment that you should have that aren't expensive and that will make your life a lot easier, especially if your design doesn't work out the way that you think it's going to work when you first power it up. So I'm going to show you a couple of pieces of test equipment along with a number of different types of test cables you can use to test, fine-tune, and troubleshoot your designs. So here are just a few test leads and some equipment that can make your prototyping and breadboarding a lot easier. I say a few because I've got lots and lots of test leads, but I brought a few out that I thought you should take a look at because you'll want to stock a few like them yourself. Now, the first one is one that has these little miniature alligator clips on each end, and this is a very, very handy thing to have. I always have dozens of these things around. They're great for jumpering connections, etc. You really don't want to be without these, so you can pick these up in 5 and 10 packs in various colors. I'd advise you to go ahead and do that. You can also get some more specialized ones. Here's one, actually I made these ones myself, that have alligator clips on one end and banana plugs on the other end, so when I'm going from a power supply to something, this can be very handy, or when I'm going from my test meter to something, it can also be handy. Now, this connector with a banana plug on one end has one of these little gripping hooks on the other end, and these are very good for getting at tiny little test leads, even getting at leads when components are plugged into a solderless breadboard. So you'll want to get a few connectors that have these as jumpers, definitely. Here's another one that just goes from a banana plug to another banana plug, and as you saw on some of my solderless breadboards, I've got binding posts that accept banana plugs, so that's an easy way to plug it into the power supply. It's also a way to hook up a couple of meters, etc. in series or with your load or with whatever you're testing, or just a couple of meters together, because they use banana plugs as well. Here's one that I kind of made specialized. You might remember I put a 2.1 millimeter power connector in the solderless breadboard assembly that I modified, and this just takes it to a couple of banana plugs so I can bring it out to my power supply. In short, you could make all kinds of connectors yourself as well, so as the need arises, by all means go ahead and do it. Another thing that's handy to have is a 9-volt battery clip that goes to a 2.1 millimeter jack. You'll find that to be very useful for powering Arduinos, for example, when you're not powering them from the computer. Now let's take a look at a little bit of test equipment. Well, the first and most obvious one is a multimeter. Now this is an auto-ranging multimeter, but you can also get multimeters that let you select ranges. And of course, if you're going to have any one piece of equipment, have a multimeter. This wasn't an expensive one at all, and it's paid for itself many times already. This will let you measure, of course, resistance. It'll let you measure voltage, both AC and DC. It'll let you measure current, and most of them let you make another couple of measurements as well. This will do capacitance and frequency. I have another one that has a transistor tester. There's usually a diode testing on it. So this is just an essential piece of equipment. You really can't get into electronics without at least getting a multimeter. The second piece of equipment that I would advise you get once you get started and interested in digital electronics is this. And this is a logic probe, and it just connects to the same power supply that you were using, be it 5 volts or 3.3 volts. And you connect this to the power supply, and then you can probe around and find out whether a connection is high or low, or whether it is pulsing. And this is very handy when you're trying to troubleshoot logic circuits. I mean, an oscilloscope, of course, is the ultimate tool, but an oscilloscope is very expensive and can be difficult to use if you don't know how to use one. A logic probe like this goes for about $25, and I got this one on Amazon, by the way. A couple other little pieces of test equipment you might want to have on hand. This is a little USB power supply tester. You just plug this into the USB port and plug your USB device in here, and it'll measure both the voltage and the amount of current your device is drawing. And so that can be very handy, especially when you're building something and you want to know, for example, if I make a permanent version, how much current does my power supply need to have. You can use this to test your device. This is a very inexpensive, I think a $3 thing, that basically will let you test servo motors. You just attach power to it and you can move the servo around. It even goes through a couple of different modes for testing it. So it's a handy thing to have if you're working with servos. And finally, here's another jig that I made myself. Now, as you can see, I just took a USB cable and hacked it, and on the end of it I put a USB connector, but in between the two of them over here I put this little 8-pin dip socket, and so this end is not connected to that end. In order to make this cable work, I've got a jumper all for, and this is what's called a breakout box. There are situations, for example, when you want to connect USB up, but you don't want the power connected through. You can remove that jumper. It also lets me get test leads onto each of the USB pins, and so it's just wired up on a piece of Perfboard. And so that's an example of some of the cables and connectors and things that you can use when you are prototyping your project. So now you've got your project design complete. You've got it working on your solderless breadboard. Perhaps you've got a couple of custom jigs rigged up for either an Arduino or a Raspberry Pi. You've done some troubleshooting and everything is working properly. So the next step is you either say, I'm finished, this was just an experiment, or I want to make a permanent version of this project. Now, in order to do that, you're going to need to transfer the project onto something other than a solderless breadboard. You will keep building your projects on solderless breadboard and keeping them permanently, but that will get a bit expensive, plus it's a bit cumbersome, especially if you only need a few parts, because after all, a breadboard can be rather large. So the normal thing to do here is to either go to Perfboard or create a printed circuit board. Now, if you're going to be making dozens and dozens of copies of your project, the printed circuit board is really the only choice. But even if you are going to make a PCB, it is sometimes advantageous to use a piece of Perfboard first to wire everything up and make a prototype version. With Perfboard, if you find there's a wiring error or you want to make a design change later on, it's a lot easier to do. Plus, laying components out on Perfboard will give you an idea of how you might want to lay them out on a printed circuit board. For example, the robot I'm building now, the DB1, I've laid out some components on Perfboard, and I've got a thought that if I do create a printed circuit board of some of these devices, I would do it a bit differently, just based upon my experience with the Perfboard layout. So what I want to show you right now is Perfboard. I want to show you a number of different styles of it, and also some of the things we can use to make wiring up Perfboard a lot easier. I'll also show you a piece of Perfboard that I've wired up myself. So let's go take a look at that now. And so here we have a veritable sea of different Perfboards. Now you'll notice these ones seem to dominate, and there's a reason for that. I really like these styles of Perfboards. As you can see, they're available in all sorts of sizes. These can be purchased on Amazon or eBay. What I like about these boards is, first of all, they're glass epoxy, so they're a good high quality circuit board. Secondly, they are plated through, so they actually have plated through holes, and that will make the soldering a lot easier when you're working with the Perfboard. And as you can see, we can get them in virtually any kind of size. So if I were you, I'd stock up on a few of these sizes, and then you'll never be without. And you can also cut these as well, by the way. Now, this is a lower quality Perfboard, the type I wouldn't recommend. It's single-sided, it's not plated, so you can see it's already starting to oxidize. And these pads will come off very easily when you solder. Now, these are very commonly available, but I would stay away. They're also not glass epoxy, they're phenolic. So after a while, especially if you're mounting components like transistors that generate heat, the board will start to warp a little bit. Now, this is a higher quality glass epoxy single-sided board, but it does have the holes at least plated. They're not plated through, but they're plated. So this is an acceptable quality board as well. This is another one that I wouldn't recommend. Again, a non-plated through board that's just basically the copper. These ones come with small project cases, so when you buy a project case, you quite often get a board like this inside. And you can use these for a couple of projects if you wish, if it's something not critical. But for anything that you're prototyping and you're serious about, I would strongly recommend one of these types of boards. Now, when you're prototyping, you're going to want to use things like sockets for your ICs. So I've got a number of sockets down over here, 14 and a 16 and an 8 and the 28 pin one. And I've also got this row over here that you can snap off to make any size pin that you want. And these sockets I really like. These are the higher quality IC sockets, and they are gold plated on the inside, and they make very, very good contact with the integrated circuit. I wouldn't recommend soldering integrated circuits directly when you're using Perfboard. It just makes it a lot easier down the road if you need to replace one if it's in a socket. Now, here's an example of a Perfboard I've been working with. Those of you who are following my Build a Real Robot series will recognize this board, of course, as being my motor controller board. It's got a couple of Arduino Nanos on it, and they're mounted in female header sockets, so they're not soldered directly in. I've also soldered a couple of connectors onto it, and as you can see, there's a capacitor there as well. Now, the way that you wire this up is you want to use small wires. I really like wire wrap wire. I don't know if you can see it very well because one of the colors I chose happened to be green and the board is green. But there's a yellow one and some white one here as well. The wire wrap wire is very thin wire. It's 40 gauge, so you need a special wire stripper, but it's really great for connecting logic signals up. Now, this heavier wire here is 22 gauge, and I use it basically for the power and ground signals, which I want to give a little bit more copper to than I do for the logic signals. But with a little bit of practice, you'll find working with Perfboard is very easy. And even if you are eventually planning to make a printed circuit board, it's a great way to figure out how to lay out the components and all that on your design. Okay, well that about wraps up today's video. I hope that you enjoyed it, and I hope that it's opened your eyes up to a few little pieces of test equipment or jigs or tools that you can use during the prototyping process. Now, if electronics and working with Arduinos and Raspberry Pis is something that is new to you, I also hope that it has shown you then that it is not an expensive hobby to get into. With a very small investment, you can have a number of these different tools and pieces that I've shown you in order to make your prototyping a lot easier and a lot more enjoyable. Now, of course, as with all of my videos, you will find an article that is related to this video on the dronebotworkshop.com website. You'll find a link to that right below the video. And while you are on the dronebotworkshop.com website, please consider joining my newsletter. It's my way of keeping in touch with you and also of finding out what content you would like me to create for you. And as well, if you have not subscribed to the YouTube channel yet, please do so. I would be very appreciative of that. So once again, please take care of yourselves. I hope you have fun in your workshop, and we'll see you again in this workshop very soon. Goodbye for now.